That's all it is now. So what is the angular velocity formula? Angular velocity is equals to 2 pi by time period. So that's all it is now. So initial radius square into what is the initial omega? 2 pi by initial time period, which is equals to RF square into. So what is that, guys? What is the final time period? 2 pi into final time period. That's all it is now. So 10 power 4 initial radius whole square into 2 into, anyhow, both the sides I can get cancelled. What I can get cancelled, everyone? 2 pi get cancelled. Okay, please respond. Divide by initial time period. What is the initial time period? How many days it is taking? Initial time period 30 days. Final radius 3 square divided by final time period. That's all, guys. You can solve it, you will get the answer. So 10 power 4 whole square means 10 power 8 divided by 30, which equals to 9 square, 9 divided by TF. So I can make it now. You can see that. So TF will come this side, it will go like this. So which is equals to 9 into 30 divided by 10 power 8, which is equals to time period. That's all it is. So this is what is the total time period of a after internal collision. After internal collision, that is what is actually exactly the time period. So you can calculate it and you can tell me the value also. Are you clear, everybody? You understanding, Amma?
Yes, sir.
Yeah. So
Yes, sir.
sure, let's solve it, everybody. Complete it, make it fast. Anything doubt you can ask. Completed?
Yes, sir.
Okay. So next question. Now, it will be see that this question is even more interesting, but you have to solve little faster. So let me take two discs now. So you all just imagine two discs. Initially, they are separated, guys. They are not attached. So two same size discs where the axis of rotation is passing through the center of mass. So now this discs has been just I'm showing the arrows means they have been attached to each other after that. So that is the meaning of it. Okay. So now this disc is actually rotating like this, and this disc is also rotating. Actually, disc actually it is. So disc with the initial inertia is that is, and angular velocity is 2 omega. This disc initial inertia is 2I and angular velocity is omega. Okay. So find the common angular speed of 2. That is what is the question. Find the common angular speed of 2 disk when they will start attaching. So now all of you observe, when they will come and contact each other, definitely there will be exchange of momentum. Am I right or wrong? Everybody, please speak, guys. Everyone, all of you. Yeah.
Yes,
So
sir.
that is very important. Okay. So when they combine, before they are individual, after that they are working together. So that is very important. Now you can see. So I can apply very simply, you can solve. Just I'm giving you time. So option A is 2 by 3 omega. Option B is 3 by 4 omega. Option C is 3 by 2 omega. Option D is 4 by 3 omega. Solve it now. Try, everybody. 1 minute time. Everybody try. Answer, please. Yes. Hello, Sudreswar. What is that? Apply that initial angular momentum equals to final angular momentum. That's all. Initially they are individual. After that they are combined. That's all it is. So what else is there? So you can see that. You can use that formula, you can get it. That's all. So only combined angular momentum will change. So now see, when both will combine, definitely there is a change in angular momentum. Am I right or wrong? Everybody, will you all agree with me? Yes, please respond. All of you. That's
Yes,
all.
sir.
That logic, if you lose it, you will get the answer. So nothing else is there. Okay. So now let us see that how I will solve. So I will apply the conservation of angular momentum. So initial angular momentum is equals to final angular momentum. Initially both disks are separate. So disk 1, what is that? I into initial momentum is I, sorry, inertia is I. And what is the angular velocity? Check it, everybody. What is the angular velocity? Speak Ra.
2.
2 omega. That's all. 2 omega plus second disk. Second disk initial inertia is how much? Inertia is how much?
2i.
2i, and angular velocity is what? Omega. So
Omega.
2i into omega, which is equals to. Finally, after that, both are attached. Attached means what will happen? Inertia. This is 2i and this is I. What is the inertia? Inertia will become, yes, please. 2i plus I, which is equals to how much, inertia? Inertia is equals to how much, guys? Inertia is
3i.
equal to 3i. But what will happen? Omega does not be, because combined means omega will change. Let me assume that is omega dash. So which is equals to 3i into omega dash. That's all. So what will happen? Everywhere II is there. So II will get cancelled. So what is remaining? 2 omega plus 2 omega, which is equals to how much remaining? Everybody. 4 omega. So
4.
4 omega is equals to 3 omega dash. So omega dash is equals to 4 by 3 omega. So what is the answer? Anybody? Yes, please. Option D. That's all it is. Okay, everybody. So that is how you have to solve it. So 100% I'm saying you in your NEET exam and your whatever the both JEE exam, there will be a question related to conservation of angular momentum. If you practice 100 sums also, definitely still you need more practice for getting more fastness. So that calculations, any short way is there. I'll discuss and I will say you tomorrow. And then we'll continue in our tomorrow's class. The next rolling concepts. So the same thing. So translation, already we studied translation plus rotational motion. So the both combined we used to call it as what? Everybody. Translation
Rolling.
we used to call it as rolling. So when the body is in rolling purely, so how it will be, how to calculate everything, what is the time period, what is the distance, how it is, that is all the things we are going to discuss with with respect to ground. So what is that? That all the things we'll discuss in our tomorrow's class. So from tomorrow we'll start. So till that, now morning you wake up and take the sums of many materials you have. So take at least 10 sums, 1 hour, 60 minutes, try to solve 6 sums at least, each 10 minutes, one sum related to this conservation of angular momentum. Then only will become good. Okay. So I'm expecting everybody will follow. I don't know. Mr. Rudresh, are you following?
Yes, sir.
So okay, do it and we'll meet in tomorrow's class. Thank you, everybody.